Hello, hi, good evening, everybody. Good evening, Rakesh. So, Rakesh, before we, good evening, everybody. Rakesh, before we get started, just
Yes, sir.
confirming whether you are able to see me and hear me clearly.
Yes, I can see you and hear you, sir. I can see the
Okay,
presentation also.
you are seeing the presentation. Excellent. So,
Yes.
without much ado, I think we'll get started. So, welcome everybody to the second session in this webinar series. While we get started, Rakesh, one of the things is that as new participants keep entering, you will be able to
We will
handle
admit them, sir. We will
the
admit them.
entry and exit, right?
Yes.
Somebody's monitoring because it's flashing on my screen.
No, we will admit them so you can carry on with the session actually. We will
Okay,
take an
great.
admit.
Great. So, hi all. In this session, session number 2, we will explore the AI specializations and industry applications, right? Continuing from the introduction to careers in AI that we had in session 1. So, as always, I will start off with a teaser or a puzzle. This puzzle is called Unlocking the Future, right? So you have a data set. The data set has got 100,000 or 1 lakh emails. So how can you efficiently identify spam messages using machine learning algorithms, right? So this 100,000 emails also has got a column which says whether the email is a spam or it's a ham. Basically, ham means not spam, right? So what features would you consider and how would you classify them? That is the question. So as always, I'll make this session very interactive and throw open the session to the audience right from the word go. Okay. So I would like all of you to start chatting and then tell me, how can you efficiently identify spam messages? What techniques do you use in the context of machine learning algorithms? Kaustubh says emails from unknown domain names or long domain names. Yes, correct. Typos is another thing I've seen. Yes, these are general answers, right? Emails from unknown domains, typos. Then what else? What are the other ways in which we can identify whether it's a spam or not? Certain keywords, says Arvind. Like what, Arvind? Yes, correct. So keywords like you have $1 million or keywords like winning or excited or this is the refund is another keyword in the context of the current income tax filing that most of us are doing or have done last week, right? One of the spam emails that you can get is, hey, there is a refund for you. Would you like to click on this link, right? Inappropriate links. Yes. Yes, correct, Kaustubh. Emails to show urgency for financial transactions. Like, your fixed deposits going to mature. Would you want to redeem it? Would you want to renew it? There is a urgency for that. Or the bank is going to shut down. Do you want to redeem your savings bank account balance? What else? What about HTML links? Compared to the normal emails, if the email has got an HTML pasted link, right? That's another alert, red alert, or sign that it could be a spam mail. Let's discuss the most important second item, right? What features would you consider and how would you classify them? So what are the features that you would look at to see whether the mail is a and how do you classify? You can also tell me what techniques do you use to classify them, spam or ham. So what is the statistical method that you would use to classify, a business problem into a win or a loss, a 0 or a 1, right? Can someone tell me what is the technique that is used? Excellent answer from Shubham, right? Simple features like word count, n-grams count, or embeddings from language models like BERT, right? We will discuss that later during the session, but you look at the, fundamentally what you would do is that you would take each email, then first do a data cleansing. How do you do data cleansing? First of all, you remove all punctuations, exclamations, commas, hashes, all that you would remove. Then you convert all capital letters to small letters so that the message becomes very succinct and it is like a lowercase text message, right? Then you count the number of words. Then something interesting that he brought about is bigrams, trigrams, n-grams, right? You do an n-gram count and then you see whether, you know, there are additional indicators like embeddings, right? So these are good ways of considering the feature, right? Now, the answer is, like we discussed, one is features, word frequency. How frequent are the words coming? Like if there are too many wins, oh, you're going to win, or excited, or like, or, you know, words like good and all that. Word frequency is one indicator. Sender reputation, the email ID from where it would come, right? If it is a proper email ID from a reputed organization with .org, .com, and all that, .co.in, these are domain names which indicate that it's safer, right? But if it is a domain name which we don't know, then it's a signal or indicator. The other thing is content analysis, right? We use a technique known as TF-IFD. We'll talk about this later, right? So using those feature engineering and algorithms like naive Bayes or support vector machines. These are typical algorithms that we use for classification. So naive Bayes comes from the Bayesian algorithm, which says that all of you would have studied in your math. I think there are 4 mathematics courses, right? In the first 4 semesters. One of them would have taught probably the second semester when probability of A given B equal to probability of B given A divided by probability of A intersection B. That's the Bayes algorithm. Same algorithm is used in naive Bayes classification. Support vector machine is a slightly different, but typically when we do machine learning models, we do both the algorithms. We implement naive Bayes, we implement support vector machines, and then look at the results. Their results, like I told in session number 1, are typically looked at based on the confusion matrix. The confusion matrix has got 4 metrics, basically accuracy, recall, precision, and then F1 values. These are the 4 metrics that you would look at for both naive Bayes support vector machines and see whichever gives a better indicator, right? With a recall value closer to 1 and higher accuracies, you would consider that model. What is the connection to artificial intelligence? The connection here is that, remember that we spoke about 1 lakh or 100,000 records or emails. So the ability of AI to handle large data sets and thereby extract meaningful patterns. So that is the problem solving skill that AI brings to the table. Okay. Now, I also wanted to look at some of the recent breakthroughs in AI. What is the future holding for us, right? So recently, Google's DeepMind, it solved one very important unsolved problem, which was the protein folding problem. And most of the biologists were taken aback because the biologists traditionally didn't want any math or any machine learning problems, algorithms to step into their territory. But when they saw Google's DeepMind solve this problem, this protein folding problem, it's called the AlphaFold 2 project, they were flabbergasted. They were like, wow, machine learning can do so much in domains such as our field as well, in protein folding.
Texas Instruments has been advancing space electronics for more than 60 years. From our first steps to the giant leaps in our furthest interstellar voyagers, and for the steps yet to come. We're your partner in engineering the next frontier.
In 2020, DeepMind's AlphaFold 2 solved a 50-year-old biology challenge. This is one of the biggest advancements in AI and structural biology in decades. In this video, I will explain simply what this means and what advancements we can expect next. The first thing to understand is that there are amino acids, which are the basic building blocks of life. Think of them like Lego blocks. With those Lego blocks, we can build proteins. So amino acids and proteins are both the building blocks of life, but they are also the machines that make life work. That's what allows us to see light, to move, to breathe, and to metabolize the things we eat. Each protein has an intricate shape that defines what it does and how it works. We know of over 200 million of proteins, and that number is going up as we discover more and more. But humans have been pretty bad at understanding the exact 3D shapes of all of these. So if we're looking at a Lego castle, we know which Lego pieces are used to build it, and we kind of know what the castle looks like. We just can't build an exact replica of it.
Unravel a protein, and you'll see it's like a string of beads made up of 20 different types of amino acids. Interactions between these amino acids make the protein fold, as it finds its shape and almost limitless possibilities. For decades, a community of scientists have been working on a way to figure out a protein shape just from its string of amino acids. This is a major challenge in our understanding of biology.
Our ability to understand protein folding would allow us to understand the actual machinery that makes life function. The sequence of amino acids is folded into unique and specific 3D structure, which determines the protein's function. It's important to understand that a string of amino acids can fold in many different ways. In fact, that's an understatement. To give you an idea, the number of atoms in the universe is 10 to the 82nd power. Yet the number of unique ways a protein can fold is 10 to the 143rd power. These are unimaginably large numbers. So basically, it would take an enormously long time to go through all the possible configurations. Yet proteins can fold in seconds or less. This, by the way, is called the Leventhal's paradox. So out of the 200 plus million of proteins that we are aware of, we were able to determine the exact 3D structure of about 170,000 of them.
So this is exactly the power of AI, right? So 10 power 143 combinations are there, about 200,000 ways in which protein can fold itself. Out of the 200,000 ways, 170,000 ways, right, which is 85% of the possibilities have already been unraveled by AI, which is humongous, right? And that too within a short period of time compared to what human researchers, right, biological researchers have taken so many years to get even to a fraction of what AI is capable of doing. So that's entirely the power of AI. I will quickly move through the rest of the video. I mean, the crux of what I wanted to cover is already
to map out these 3D structures in the real world. Well, the ability to understand protein function would allow us to know the unknown functions of proteins in our DNA, as well as quickly design new proteins that alter the functions of other proteins. This would be massive for pharmaceutical development, for our ability to understand and to change the genome. This would allow us to treat many diseases, create biomaterials that we can use in building as well as agriculture. Tissue and organ regeneration might be possible, as well as supplements for health and anti-aging.
Yes, so the implications of this breakthrough is that you can bring about changes in the field of medicine, healthcare, agriculture, right, food. So all possibilities are showing up thanks to the power of AI, right? That's the message that I wanted to leave you guys with.
In the long term,
so let's move on to understanding AI, the basics of AI. What I'd suggest is that you can continue to keep asking me questions or queries on the chat box all through. It could be related to the slide on the screen, or it could be something else as well. But then I would, spend less time on talking through the slides rather than hearing from you guys and making this session interactive. Okay. So most of you may be aware, AI is divided into broadly machine learning and deep learning, ML and DL. Machine learning has got supervised learning, unsupervised learning, and reinforcement learning. Let's briefly spend time on what each of these definitions mean. Supervised learning means you have the labels associated with the data given. So the target variable values are already known, and therefore you use train test methodology to come up with the model, machine learning model. So in supervised learning, you already know the results of the target variables. In unsupervised learning, you would not upfront know what the target value or target variable is, and you discover patterns as you go along doing this unsupervised learning models. For example, typically this is used in classification. If you are looking at a market, like a laptop market, for example, unsupervised learning will look at demographic characteristics like age, income, then the location, geographic location, then the occupation that you are doing, all these parameters, and come up with categories or customer segments like Gen Z or families with kids or senior citizens. Depending on each category, you can position your product like a laptop, right? Senior citizens may want a bigger screen, sturdier keyboards and stuff like that. Gen Z or the younger generation may want gaming with a lot of GBs of RAM, ROM, hard drive, etc. While the families with kids might look more for professional kind of setting and a lot of checks and balances to make sure that kids are safer in that environment. So you can design your product depending on the classification. So unsupervised learning is used that way. Reinforcement learning, again, reinforcement learning has multiple subcategories, but one of the key things is that it takes a lot of feedback into consideration, right? So there's a feed forward loop and then there is a backward loop. So reinforcement learning takes into consideration feedback loop in the algorithms. Under deep learning, there are three types: the convolutional neural networks, CNNs, then you have relational neural networks, recurrent neural networks, RNNs, and then you have what are called general adversarial networks, which are GANs. And currently the chat boxes, ChatGPT, DALL-E, the prompt-based tools that we are using in Microsoft's Copilot on Bing browser, all these are based on what are known as the GANs, right? GANs are the fundamental building blocks for coming up with ChatGPT kind of tools. Now let's move on to what type of specializations if you are choosing a career in the field of AI, right? The first thing that you have to think about is there are multiple specializations. So what kind of specialization do I need to do? The first specialization is called the machine learning. That is the core or the heart of AI. Under machine learning, you would have supervised learning, unsupervised learning, and reinforcement learning, right? We learned about it in the last slide. What does supervised learning consist of? It consists of two subcategories. One is the classification and another is regression, right? So in classification, you would typically, again, you look at a 0-1 kind of a thing, right? So classification means if I'm a bank, I would like to look at from an acquisition point of view. Will this person open a bank account with me or not open a bank account with me? Will this individual with such and such demographic characteristics subscribe to mutual funds, not subscribe to mutual funds? Will get on to PMS portfolio, not get on to PMS portfolio? 0-1 kind of a thing, classification. Regression means, again, it could be different types of regressions. It could be linear regression. It could be, again, logistic regression would be more under classification, but linear regression would have weightages coming in it. There are various types: lasso regression, ridge regression. We will cover all those things as part of the course that Insights AI offers. Right? Under unsupervised learning, there are two types. They're called clustering and association. Clustering typically means there are a lot of clustering algorithms like k-means algorithm. Right? Again, these are used to find out categories and subcategories, segments. Segmentation is one thing that typically lends itself to clustering. Then you have association kind of problems. Under unsupervised learning, again, since we don't know the target variable, what would we do? We don't know the result. So association means it's a technique by which you bucket together, right? Market basket analysis is a typical example of association in retail. So if I buy a toothpaste, would the customer also buy the toothbrush along with it? So you analyze, say, 100,000 invoices from the point of sale system and then identify or associate one product with the other. For example, toothbrush with toothpaste, right? And you've come up with various hypotheses. If they buy onion and garlic and say tomato, are they also typically buying burger, right? Or ham or whatever, right? So these are all association rules that you come up with, and you test those rules using these techniques. Then under reinforcement learning, you have model-based methods, model-free methods. So reinforcement learning means it depends on the state at which the agent is. We have three key words or key ingredients to reinforcement learning. For example, you can think of a robo, right? And the robo has to navigate a path, right? A complex path. And the reward for the robo is, say, a diamond, right? While it is navigating this n by n matrix consisting of a lot of dangers like fire, then boulders, etc. in between, right? The robo can be considered as an agent. The agent, depending on the state or the position that it is in, has to take a call as to what is the next step that I have to take. What is my n+1 step, right? So in order to determine that, model-based methods already look at the patterns upfront. It is similar to if you want to move from, say, your IIT Madras campus to T Nagar, right? So in model-based method, the Google Maps already shows you the distance, the direction, the traffic conditions, what is a threat, what is a non-threat, what is a smooth passage, etc. In model-free methods, you take a call on that exactly at the state that you are in. So depending on the available information, the agent or robo would move to the next step. At that step, it would look at the next step to be taken based on the parameters. So model-based methods have environment as a variable that you input into it upfront. Whereas in model-free method, environment is not considered upfront. The agent would take a call on its state and the next step and move towards what is known as a reward. Now let us think of the machine learning career opportunities. So in the meantime, let me see if I have any queries on the chat. What are the type of career opportunities for a machine learning engineer? Early level, entry level roles, right? One of the entry-level roles typically that organizations hire for is a data analyst role, it's a junior data scientist role, and a machine learning engineer. And these roles are pretty much across all domains today. You could join a banking firm, a financial services firm, or a fintech. You can join an insurance company. You can join a manufacturing company, right, as a machine learning engineer. You could join oil and gas. You could join retail industry. Right, you could join a Reliance Retail, or to join a bank like a Wells Fargo, or any of the retail outlets, right? MK Retail, for example, they also use a bit of data analytics and machine learning. Mid-level roles. As you start navigating the career path, you reach across after a couple of years to senior data scientist role, ML researcher roles, AI specialist roles. I will walk you through in my next slide what typically is involved on a day-to-day basis. What would I do daily if I join a company as a data analyst is what we will look at now, and then revisit these slides in terms of the other things like skills required. So the role of a data analyst, right? Feel free to punch in your queries on the chat box. The role of a data analyst is, first is you do data exploration, right? You'll be given raw dump of the data, or you have to uncover the data. A data engineer or a database person would pull humongous amounts of data, say 100,000 records or 1 million records of data from the data warehouse. The dump would be something which will be dirty. You will have to explore that dump and examine to uncover what are the insights or trends that can inform decision making. So it would involve data cleansing, data deduping. How do you impute? Imputation is very important. Missing values. One of the easy ways of imputing missing values is the median, or in some cases, the mean. So you have to take calls in terms of how to explore the data. This is a very important part. This could take up to 50% of your project time. Then comes the data visualization. Data visualization doesn't necessarily mean you have to use sophisticated tools like Power BI or Tableau. It could also mean that you would use tools like Excel to create line charts, bar charts, to communicate what are the findings of the data, go back to the business and ask them whether these patterns make sense, right? Whether these are things that align with what the reality of the business is, right? So That part also comes under a data analyst role. Of course, we spoke about data cleansing to ensure consistency, accuracy. There's a lot of pivoting that is required in data. The key thing to look for in data cleansing is you typically get data in the form of a XLSX or CSV file. That is typically what you get. But you have to actually look for rows with the keywords as the primary key or the ID that you have should not get duplicated. If it duplicates periodically, for example, every 5 rows you find the same kind of ID, right? So you do a pivoting, or you do ensure that a combination of attributes or a combination of columns ultimately becomes a key. That is the clean data position that you should have before it is given to the machine learning engineer to run any machine learning model. So data cleansing would mean that you have to start thinking relational databases or types of databases. The entity relationship diagram thinking is very crucial for data cleansing, because you will then identify what combination of keys will result in unique rows. Then you also make some reports, recommendations, actionable recommendations. So every month or so, if you have a monthly review, you would do a discussion with the business to see whether your findings, your recommendations are things that they can relate to. Okay. Let me pause here and then take some questions that have come up on the chat. Nagarajan says, I'm a doctorate having 21 years experience. Can I change my domain at this point of time to data science or AI engineer? Will I get chances in the industry? Definitely yes, Nagarajan. I think the average number of years of experience, right, is going to increase humongously in the current era, right? In the previous generation, probably about 58 to 60, 62 was when people used to retire. But now I think people are starting their careers in the early 40s and mid 40s too, right? So even with the 21 years of experience, I'm assuming that you would be in your early 40s or mid 40s, right? You have another 15, 20 years to go. So definitely, rather than I would say change the domain, my suggestion is that there is no domain in AI, right? AI is an enabler across domains. So whatever domain you have, if you can also punch in what are your specializations in domains, then I can accordingly advise you what courses to do and what opportunities will be there in those industries. So by all means, go ahead and then, yes, I understand you are a chemical engineer, but you are teaching. Okay, do you do consultancy in any specific domain in chemical engineering, like oil and gas or textiles or tires? Okay. No worries. The good news is that AI cuts across all these domains. So my suggestion would be in the manufacturing domain, there is huge opportunity because all of them are embracing Industry 5.0. They have recently moved to Industry 5.0 from Industry 4.0, which means if you don't embrace AI in terms of analyzing your sensor and actuator data on machines and identify patterns. See, most of these machines run 24/7. So you need a plugin into those machines to gather data, analyze the data live as they are doing, and then implement them live, right? So I have seen chemical engineering industries where the machines keep running, but changes to the machines, transitions are done while it is running using AI, right? Typical example, robots. Robots can go without any danger, go and then replace parts. Spare part is one area where you can focus on. There is huge opportunity there. What kind of spare parts, especially in the Indian context, they have not been paying too much of attention since the license Raj on spares, right? They would only focus on the core products. But now I think time has come where spares are contributing to a major share of the revenue. And therefore, how do you replace spare parts while the machine is live and on? These are some of the problems that you can think of. Yes. Reporting and recommendations is something that's the role of a data analyst. Let's go back quickly to the skills required, right? Obviously, Python is something that all of you, I would recommend do a small course or something. In programming, if you're interested, you should have an intrinsic interest in programming languages. But these days, even with simple English, you are able to generate code. That's the good part. Statistics, you should have a good understanding of statistics. Basically, mean, median, mode, and then normal distribution, normal curve, what is mean, mu, and then what is sigma. And when you take a sample from a population, what is the difference between population? What is the difference between sample? What is the difference between, say, mu and x bar? What is the difference between sigma and then the sample variance? Right? These are some of the concepts that have to be crystal clear. Otherwise, this subject will confuse you a lot. What are the type of machine learning algorithms, right? What is the difference between a linear regression and a logistic regression? Surprisingly, when I interview candidates, right, and I've been on the other side for almost 20 years now, candidates who have been working in the industry with 2 to 3 years experience, if you ask them what is the difference between linear regression and logistic regression, they would still blink, right? Because they have been taught certain techniques. You use this technique irrespective of the context, right? Therefore, the model fails. Hence, it is very important that you understand what exactly is this model doing, right? It's called feature engineering is very important. What are the features that I would take into this model, right? What are the features that I would discard? Of course, to do that, your basic math has to be strong. Matrices is very important. Determinants, matrices, linear algebra, coordinate geometry, trigonometry to some extent, right? So I say matrices because most of machine learning depends on, you should know how to multiply matrices, transpose of matrices, right? Those are very important conceptually, because when you are dealing with huge amounts of data, you are dealing of the order of 1,000 by 50 kind of rows and columns, matrices of 1,000 by 50 by 20, and when you multiply it with another 500 by 20 by 40, you should be able to visually see how the matrix multiplication operates for you to code the right kind of equations into the code, right? Teja has a question. Teja Surya, does taking GATE in data science and pursuing masters be a good way to get started? Absolutely, Teja. That will be a very good way, provided you are not doing data science and AI in your graduation, right? In your graduation, if you have done data science and AI, I would suggest that while taking GATE may take you more towards research and academic pursuits, right? It's not necessary. My belief currently is that increasingly the academic degrees are becoming irrelevant, right? What is relevant is skill building. So if you look at the popular online courses that I've mentioned on the slide, right? There is a Udacity. Udacity has what is known as a nano degree program. Nano degree is a very, very interesting way to look at education, right? In nano degree, what happens is that you sign up and then you take certain online lessons, right? And some capstone projects and get certified there, right? So your payment will be post taking up all those online courses. You can also, interestingly, do audit on courses. Auditing the courses is a very good way of learning about them. And if you get these kind of credentials, this is called credential-based learning, which is very popular. Industry values credential-based learning today more than academic degrees, right? I hope that makes sense. And let me look at the next chat question. What are some of the certifications? Again, Google machine learning certification, Microsoft AI certification, IBM data science. At Insights AI, we also offer a machine learning certification, which is very, very focused on our methodology. And our uniqueness is that we don't do any stack ranking. There is no competition or anything. You are intrinsically motivated because you enjoy the course. And at the end of enjoying the course, you choose a job or a company that you want to apply to. And then we enable you with the right kind of coaching to ensure that you hit the dream job, right? In terms of online courses, the Andrew Negg's machine learning course has been for more than a decade now been the go-to course. But let me mind you, content is the last thing that I would look at, right? In this coaching or teaching area, I've seen that content is available in plenty. So whether it's Andrew Negg's ML course or Harvard's data science course, it's like the analogy is that of a river, right? A river Ganga may be flowing right in front of you, but it depends on whether you are a crow or an elephant to kind of guzzle that water in. So similar is the knowledge that is available in this area. So unless you are guided and coached properly, navigating this space is also very difficult. let's move on to the typical team structure in a machine learning project, right? So in a machine learning project, typically, it starts off with a problem owner or a problem solver, right? So the problem owner would be typically the one who interacts with the business, right? For example, the problem is marketing spend, right? So marketing has traditionally been using TV, newspaper, and offline channels, billboards, etc. So problem owner from a data analytics AI side would go to the marketing department and then tell them, look, online modes like banner ads and email and Facebook-based ads, these are all powerful ways of spending money on marketing today. So would you want to explore, right? And then they would create a problem, own the problem. But then who is the connector? The project manager of the AI project would be the one who would lead and own the problem from the problem owner. Then from the AI solution side, the data would typically be picked up by the data engineer. Data engineer roles are guys who have extremely good knowledge of different types of databases, be it Oracle, Sybase, Ingress, any type of data they're able to pull and get that data dump, right? That's the role of a data engineer. Whereas a data scientist is more in terms of identifying what is the right algorithm that I should use for solving this problem. So a data scientist would also wear the hat of a business analyst to look at, hey, I have this particular data. Let me go through the attributes of the columns in the data. Let me see how many rows are there. Are there any duplicate rows? How do I clean this data? What are the correlations? For example, if I'm doing a marketing problem, there is a column called sales region. There's a column called sales zone. There's a column called sales territory. Are all these columns redundant? Can I use something like correlation, right, to understand if certain columns are highly correlated? So in mathematical terms, it is called orthogonality, right? If you represent each dimension, as they are called, each column is called a dimension. So dimension D1, D2, D3, if you can imagine it in the n-dimensional space as each row, right? Each axis would be one dimension. And for each of these dimensions, if there is a perfect orthogonality, then those two attributes stay in the model. If there is a high degree of correlation, one of them will get eliminated. For example, sales territory and sales region, both of them may have same thing, right? Age and date of birth. These are 100% correlated. So typically you would eliminate age because date of birth has, and more granular the level of data you have in the model, the better it is. So between age and date of birth, retain date of birth, eliminate age, because in date of birth, you have much more granular data, right? Similarly, in sales territory and sales region, if sales territory is north zone, east zone, west zone, south zone, whereas sales region is each state, you would retain the data at a state level, at a granular level, right? To elicit or generate more intelligence from the model. So then comes the ML engineer. The ML engineer is the person who would go ahead and build the machine learning model, right? ML engineer doesn't bother about what, he does not think about what is the model that I have to choose. That decision has already been made by the data scientist. If he says, go do a lasso regression or a read regression model, the ML engineer would simply take the data, load it onto platforms like Jupyter Notebook or Microsoft Visual Studio, run the machine learning algorithm, get the results, and output the result in the form of an Excel or CSV file and give the dump back to the data scientist. Data scientist would take it to the analyst. Analyst would do the PowerPoint presentation, put it to the manager. The manager, project manager would review all the analysis to ensure that the numbers are correct. He would be the one who would make a weekly or a monthly presentation to the problem owner, right? That is how typical team structure works in a machine learning project, right? The machine learning projects are typically, they have taken off from the software development life cycle, right? But they haven't still matured in the industry. There is no one uniform model like a software development life cycle yet, right? But most people have followed that model and come up with their own agile-based methodologies, right? Agile is very much used in the industry because it gives quick results every week, every day. On a daily basis, you can be very flexible and tweak your project. Shivacharan has an interesting question. What are the applications of AI in the insurance industry? Shivacharan, huge. Okay. For example, when you talk of insurance, right, risk management is one of the key things in the insurance industry. So if, for example, a bank has to, an insurance company has to provide health insurance for a student, right? Age of the student and the past medical history of the student is taken into consideration. So they would have risk profiling, right? How does AI help in the risk profiling? So in the risk management industry, there will be a lot of documentation that is involved in filling forms, right? And also doing what is known as checks and balances on your credit worthiness. Are you worth giving the money? Are you worth betting on, given the background and the history that you have, right? How much can I bet on you? So in this particular case, for example, we could first use documentation-based automation comes into play. So form processing. At the outset, are you eligible for the insurance, not eligible for the insurance? So your demographic, psychographic characteristics, form filling, your basic details like name, date of birth, address can be picked up, auto-populated into the form. So automation is one key piece where AI comes into the insurance industry. The other piece where AI comes in is risk assessment. In risk assessment, you can use sophisticated machine learning models, risk model, in identifying parameters which influence the risk, right? Past medical history, right? Body mass index, the weight, the health reports for medical insurance, or for automobile industry insurance. In auto insurance, what would be the base value that I have to put for the car, say, and then what are the additions there? Driver, what is the insurance for the driver plus co-passengers? Is it, how many seats does the car have? What is the accident history of the car? All these factors or parameters are taken, and you build a AI model which will output, say, a 0 or a 1, right? Approve the application or not approve the application, right? So these are some of the applications. Let's move on to the next, another specialization, which is very interesting. It's called the deep learning specialization. Compared to machine learning, in deep learning, it's entirely dependent on mimicking the human brain, right? The wiring in the human brain has been studied deeply by cognitive scientists, and they have understood how the signals are processed by the 5 senses of perception, which is your eyes, ears, skin, right, and mouth and all that, right? 5 senses. So input information comes and the brain processes that. Similar thing is done based on what are known as neural networks. So the basis of deep learning is entirely neural networks. And neural networks typically are modeled in 3 ways. You have an input layer where the data comes in. Then you have hidden layers. Hidden layers could be 1 or multiple hidden layers. And then you would have what is known as an output layer. This is called a neural network. Basically, information flows through, it's transformed using matrices, and output of each hidden layer moves to the next hidden layer. And finally, the output layer would have the required output. A simple example of a neural network is handwritten digits. You know, these days, handwritten digits like PIN codes, etc., from envelopes are scanned, and computer is able to use neural networks to identify what is the digit that has been written. Right? So that's a simple use case of neural network. And within neural networks, there is so much of advancement that broadly there are 3 types of neural networks. First one is called a convolutional neural network. Right? In convolutional neural network, what happens is that you would have an input layer, then what is known as a convolution layer, then you have again multiple hidden layers, right? And you have finally an output layer, right? So typically this is used for object detection. For example, you have autonomous vehicles, self-driving cars. So when that self-driving car is moving on the street, it would, using cameras, it would capture all the information, the street view, the signals, the pedestrians crossing the street, etc. And this image is analyzed using neural networks, and it would give a decision on a go or a no-go, right? And how is the decision arrived at? Typically, it would use boxes, red, you must have seen red color boxes to identify whether this is a human being, whether this is a signal, whether this is a another vehicle like a car or a 2-wheeler going in front. And this it does based on historical data of database of a lot of images, right? So convolutional neural networks are typically used in object detection. If you look at a picture, it would be able to, this algorithm would be able to detect whether it is a cat or a dog or a ball or whatever. So object detection is one use case, and self-driving cars is another use case. In recurrent neural networks, it's the same neural network, but it has to be a sequence of data. So your input would be a sequence of data. It goes through some hidden layers, and the output would again be a sequence of data. So typically in call centers, etc., the text data, the speech data that is called voice recordings are taken, and then recurrent neural networks are used to convert speech to text. You may ask, why do you need to use speech to text? The intelligence that a customer is provided you is more in call recordings than what the call center agent would typically type in into a feedback form. See, most organizations have feedback forms, but these call center agents are so much in a hurry in moving from one call to the other, they would not type in anything. Or for that matter, most of us, when we type in feedback forms, surveys, etc., we don't input too much into the text boxes, so that customer intelligence is lost. So in speech recognition algorithms using RNN, you take the dump of voice calls, and since they are sequentially coming in word after word, they can be, recurrent neural networks can be used to output text by text, right? So once you have a text by text output, then you can use text analytics. That is what is the other use case of natural language processing. In natural language processing, as we were discussing during the initial part of the puzzle that we were solving, we use TF-IDF algorithms. So basically take them bag of words, you convert everything, take the junk out, convert it into lowercase letters, and each email for example, each email is taken, the lowercase letters is put in the form of a matrix, right? All the keywords like and, on, the, etc., the frequency, word frequency is identified. And then using this vectorization, TF-IDF vectorization as it is called, it's again, we have to understand that when it comes to machine learning or deep learning, everything is finally converted into numbers, right? So it's converted into matrix of zeros and ones. And you look at bag of words, somebody was mentioning, by, try, n kind of dimensions in that bag of words. That is natural language processing. Then in the third dimension that is coming in and is very, very popular these days is the general adversarial networks, right? Why is it called adversarial network? Because there are two components to it. There is a generator and there is a discriminator. The usual analogy that is given in GANs is a kid and a parent, right? A kid is the generator, the parent is the discriminator. Let me take a couple of minutes to explain this GAN model, which is used in chatbots and OpenAI like ChatGPT or your DALL-E, etc. So imagine that there is a kid, and the kid, the parent asks the kid to draw the diagram of a house, right? So the kid is very young, say less than 5 years, and it is doodling. The kid is doodling. It comes up with the first cut model. So it iterates, comes up with the first cut picture of the house, and then the parent, which is the discriminator, is another neural network. So the generator is, the kid is a neural network, the parent is another neural network. The parent would take the image of the house and then verify and say, okay, this particular thing, this particular iteration, I'm okay with this model. But then the discriminator also challenges itself by coming up with the next level of the picture. That is how it is improved or fine-tuned. So from a basic house, it might come up with a house with 2 stories. So again, this house with 2 stories picture is fed to the kid, which is a generator. And the kid again doodles, and after multiple trials and errors, with a feedback mechanism in loop, the discriminator would guide, right? And that is why these are adversaries. In some sense, the parent and kids are opposite. They are adversaries who are challenging each other. And it's a very good positive loop, which will finally result in the picture or the video that you are looking at. That is the basic principle on which all these image generation, video generation, tools like DALL-E, etc. operate. What are the deep learning career opportunities? Again, many roles are there. Typically, deep learning engineer, deep learning research assistant. These are some of the roles, which would, in the first 5 years, they will become data scientist, NLP engineer, kind of promo-based roles, team lead roles they would translate into, right? Let me walk you through some of the early entry-level position. Research assistant deep learning is a very popular role in the industry across domains. What does a research assistant need? You would need knowledge of machine learning, definitely, algorithmic coding. Basically, what kind of algorithms should I use to solve this problem? Deep interest in mathematics, good grades in mathematics is something that we look at. I think even today you have 4, Math 1, Math 2, Math 3, and Math 4, right? So anybody who's still in college or just recently passed out, can you confirm that in the first 2 years, in the first 4 semesters, do you still have Math 1, 2, 3, and 4? Can somebody confirm if there are students in this group? Very important. Thank you, Shubham, for that confirmation. Yes, so these are very important. If you get good grades there, it will help you align with this domain. So they do research on the business problem, what tools or techniques to use. They use machine learning and algorithmic coding. Right? And what would be a typical team structure in deep learning project? Compared to a machine learning engine, machine learning is all about regression, linear regression, logistic regression, target variable, yes, no. I have actually the results or the values with me. I use those values and come up with regression models, right? But deep learning takes a different approach altogether. Deep learning is equal to identical to neural networks. That is what you have to keep in mind. Deep learning means starts with artificial neural networks, NN, ANN, then moves to convolutional neural networks, then recurrent neural networks, right? So the entry-level position could be a deep learning engineer or an AI researcher. What is the difference? Look at this organizational chart, right? The pillar of functional manager engineering, to whom the deep learning engineer reports to, or a software engineer or DevOps engineer reports to, is hardcore engineering, which means you should be a data person, you should know how to play around SQL queries, databases, playing around with large data warehouses, understanding the deep learning models in detail. These are all the role of a deep learning engineer. Whereas if you look at an AI researcher, which is again an entry-level position, it starts with AI architect, AI engineer, AI researcher, and a functional manager for AI. This is how most advanced organizations typically are structured today, right? It's a functional AI manager. So these people don't need to know anything about the algorithms and deep learning, neural network, etc. They will only research and identify for this problem, what are the options in terms of deep learning algorithms? What method should I use in deep learning to arrive at the solution? And they pass on that technique to the deep learning engineer to implement it. So these guys are more at one level, at a meta level above, in terms of doing research to identify the right algorithms. These people would go ahead and then implement those, right? That's the differentiation. And it's very important to know your own strengths and weaknesses to identify where exactly do I fit in these roles, right? In terms of skills, yes, understanding neural networks are important. TensorFlow, Keras, PyTorch. What are these? These are all basically deep learning techniques, right? These are libraries. If I have to talk at a very, very fundamental level, at a coding level, you import TensorFlow as TF into the platform, right, into Python. While writing Python code, you import Keras. So what are you doing there? It's a library package or a library within Python, which is very, very specific to use for deep learning related models, right? And not to forget, in the last 5-10 minutes, let me re-emphasize that client interaction skills and soft skills like communication, teamwork, these are the most important skills that are required in organizations today, more than, I would emphasize that, more than identifying algorithms. Because among IITians, one of the things that is close to your heart that I've seen is, hey, can I build a Fundu model? Everybody who builds the right model or the mathematical structure is appreciated. That's only so much, right? To navigate an organization, very, very important to build a long-term career is soft skills. Once you enter a project, you should deeply understand what is the background of the project manager. Where does he come from? Does he understand machine learning models? Remember that at a general manager and project manager level, it is not at all required to understand any of these things at a deeper level. How do you engage with them, right? You should understand their priorities. First thing that you ask yourself in a project is, what is the project doing at a top level? What is the problem it is solving for the customer? And what are my project manager's priorities? If his priority is agile methodology, if his or her priority is weekly meetings, monthly meetings, his priority is to update the management, right? I would rather align with the project manager and the organizational priority. Very, very important. And for that, soft skills, teamwork, and I think the IIT environment gives you excellent, outside the classroom environment gives you excellent skills like communication, teamwork, etc. But the only thing I would warn you is that don't use any IITian lingo in organizations. Don't, I've typically seen people from IIT with a chip on their shoulders. Chip on the shoulders will last only maximum 6 months, 3 to 6 months, not more than that, right? Because the competition in the industry is so intense that Tier 2 and Tier 3 engineering colleges today are producing awesome, brilliant guys, right? With the right kind of attitude, right? So 3 things are important when you join an organization. Commitment to the project, commitment as a rule, attitude that you bring to the table, and then quality of work that you deliver, right? Remember that in that order. I have put quality of work the last, because as IITians, I know that quality of work is a given from you guys, right? But then the other 2 are the things which will sustain you in the long run. Again, I spoke about the nano degree from Udacity. There is also Andronix deep learning, and we also have a deep learning module that we offer as part of our PGP AI and ML program, right? So you can even take that as a standalone module for about 6 to 10 weeks is what it takes to finish that module with a capstone project, right? Our deep learning certificate is also very, very valuable in the industry, right? The industry definitely values an IITian degree, right? But if it is not backed by skill that you bring to the project, I think I would give it a lesser weightage. I have already covered about our organization Insights AI. I don't want to go over it again, but what I would re-emphasize it is the intrinsic motivation part. We only look for people who are intrinsically motivated to come and join, right? We only take, mostly we like to take average people, ordinary people, and we never get extraordinary results out of those ordinary people, right? By bringing in practical skills to the table, right? And like I repeated, I'm not a great fan of stack ranking. I feel that everybody has a place in the world, and if you find the right spot for you, you can skyrocket, right? And I emphasize a lot on failing. I have seen people who fail in the first semester in IIT have gone places. And most of the entrepreneurs, if you look at it, 5-pointers. I remember that Chetan Bhagat's first book, right? Most of you would have read that. 5-point someone, what not to do at IIT, right? What is the lesson there? The lesson is that, resilience. IIT teaches you a lot of resilience. And please don't shirk from working. I think hard work is extremely important. People who are very successful in the industry today, fundamental is you put in hard work, right? I used to put in at least 2x the amount of number of hours in IIT compared to most of the people who are very brilliant, right? People who, in my cohort who were in the same group of ranks in that cohort, right? The difference today is that people who have consistently put in hard work, consistency is the key, in a chosen domain, have outshone people who have, who were very smart but did not know how to navigate the career trajectory. So with those words, I would leave the last 5-10 minutes for questions and open forums. I'm open for the next 10 minutes. We can probably stretch this a little bit. All of you are okay. Over to you guys. Rakesh, we can even have the audio on if somebody wants to speak.
Sure, sir.
For all the youngsters in this forum, one thing I want to tell you is that the early 70s batch has come back to me after the first session saying that they want to learn by downloading free downloadable tools. So perhaps after discussion with Rakesh, If not this month in August, after September, we might have another series of webinars for the people who have crossed 70 today, right? The early 70s batch would have crossed the age of 70, and look at the excitement in them to learn, right? So I would encourage all the youngsters, open up, chat or voice out in this forum. Thanks, Arvind, for those words, kind words. Rakesh, while the questions are coming up, can you please share the feedback form link on the message? Or even I can do that. It would be better if you are able to. I will stop sharing the screen. If you can punch in the feedback form.
I'll do that, sir.
Thank you. The feedback link form is there. So it has got about 5 questions. I will walk you through those questions and then tell you have to rate them on a scale of 1 to 5. 1 is you strongly disagree, it's the lowest, and 5 is strongly agree, right? And there are 5 questions, and then what you like about the session is something that you may want to provide as a short answer. So I will leave the next 5 minutes for you guys to fill in the feedback form. Rakesh, if there are no further questions, we can, keep the video, the session on for the next couple of minutes to close the feedback forms. And then
Sure.
we will reconvene next Saturday at 4 p.m. for the next session.
Sure, sir. Yeah, I will also send the presentation which you have shared today to all the participants as well as registered people with the
Yes,
feedback.
my only caveat is that, it's also got content, other content. So I will post the session, call you, and then discuss and send you an abridged version of what I have covered today. That would be more useful for the participants.
Understood.
There is a question on the chat window from Shubham Kashyapi. How should an AI engineer navigate an interdisciplinary work environment, which includes AI experts and domain experts who have background in finance, manufacturing, and not in AI? Very, very interesting question, Shubham. I think the most important thing for an AI engineer to realize is the scope of his or her role, right? You should not get too excited and then navigate across the organization. Understand what is the job description, your role clearly, where does the scope of the role end, and discuss with your team leader or manager that my scope of work ends here, right? If it involves interaction with domain experts, well and good. If it does not, most likely at entry levels, it will not involve interaction with the domain experts, because the project manager or the organizational leaders are the ones who would talk to the end clients or internal clients in captive organizations, right? So they are the ones who would take the business requirements, translate the business requirements, and the project manager would translate that requirement into a language, to a machine learning language or a pseudo code that you can understand. So I think in terms of navigation, focus on the skills that you can bring to the table. Thank you, Dr. Vasudevan. Thank you, Shubham. So the feedback forms will be collected by Rakesh and will be shared with me. If you have not already done, I would say please go ahead and before you leave the session, fill in the feedback forms. Thanks, Asim Bhatia, and look forward to all of you joining me next Saturday at 4 p.m. same time. And over to you, Rakesh. Thank you so much.
Thank you so much, sir. And this is a very informative session, and I hope everyone enjoyed this. And next week we'll be having this next set of sessions happening at the same time, and I invite everyone to join in.
Thanks, everybody.
Thank you.
And then see you next.